What's up guys, Vylocity from Pitchfork Academy here, back with another Unreal Engine 5 material tutorial. In this video, I'll show you how to create a simple post-process cell shading effect. It's similar to my ultimate post-process cell shader tutorial, but streamlined with only the necessary features to get you started, along with some new tricks I've learned to help improve the overall effect and performance. But just before we get started, if you guys like what we do here and you want to connect with more like-minded people, access to our Discord server, Mizzo's Dizzo, is available for just $1.50 per month via Patreon. The Discord server is becoming a pretty cool place to be, with tons of very cool, very helpful, and very smart people, as well as an integrated AI chatbot to help you with all of your Unreal Engine 5 related questions. Your $1.50 actually goes towards that AI chatbot because it is a paid model and is indeed very clever, as well as helping support us in what we do here at Pitchfork Academy. Without further ado, let's get into the tutorial. Alright, here we are in Unreal Engine 5.6, and the first thing that I want to do is just to make a materials folder if I don't already have one, so I'll just make a new folder and call it materials, and then inside of here, I'll create a folder for post process, just so we keep our materials folder organized, and then inside of here, I'll finally right click and create a material, and I'll name this m underscore pp for post process underscore cell. And then I'll double click to open this up. Great. Now, right away, we can change the material domain on the left from surface to post process, and then we should only have one output pin for emissive color. And then the other thing we need to do is scroll down in the details panel and find blendable location and change it from scene color after tone mapping to scene color before DOF. And then from here, we can start to get out some nodes to create the cell shading effect. The first node that we'll need is a scene texture node. So I can search for that. And then this has a lot of settings on it as well over on the left under scene texture ID. So we can change it from scene color to the post process input 0. And essentially what this is our scene as we see it normally. So if I plug this in, you can see the preview sphere here. It looks just as normal as you would expect from in a normal material or in your level. So this just gets the scene that we usually see. And then after that, we can copy this and change it from post-process input 0 to base color for lighting. And then from here, we need to get 2 desaturation nodes. So I'll just get one and paste it down below. And the color goes into the first pin, and it can be left blank on the fraction part. I'm just going to move this up here slightly. And then we just need to divide these together. Make sure that the post-process input 0 goes into A. And then after that, we can saturate it. This just keeps it between 0 and 1. Now, I'll plug this in here just so we can preview what this does. This just returns our lighting information without any color. And you can actually see the same thing if you go back to your level and change it from lit to detail lighting. This returns a similar channel of information, and basically we're going to use this to create a harsh black and white mask instead of a gradient as you see here. I'll change this back to lit and bring my material back. All right, after the saturate, to remove a pin like that, by the way, you can just hold Alt and click on it and it will disengage it. After this, we need a way to control where that band starts. So I'll get a saturate, or sorry, not a saturate, a subtract node. And then I'll get a scalar parameter. I'll hold S and click on my keyboard to get one of those. And I'll call this shadow bias. Default value for this needs to be 0.5, meaning halfway between black and white. That's where we'll get our line for the 2 different shadow bands, or 2 different light bands, I guess. After this, we can grab a multiply node, and I'll just copy and paste this shadow bias, and I'll call this shadow contrast. And this can be a pretty high value. I'll set it to 50 by default. And then we need to saturate it once more, just to make sure that the values stay between 0 and 1. And then we can drag off of this and search for a reroute declaration node, and I'll call this lighting. And now we can basically right click anywhere and search for lighting, and we will get the same information that is before this node. So it's just a local variable. drag this down here, and then I'll select all this and click C, and I'll call this lighting info. And then from here, we can go ahead and do the next step. So that's our lighting information. This creates the harsh band. I think we can actually visualize this really quickly. As you can see here, doesn't look the best in this preview sphere here, but you get the idea. We have the lighter band and then the darker band here. So now let's go ahead and improve this. So down here we have our lighting, and we need to blend between our original color of the scene and a darker version of that color. That'll be the shadow. So to do that, we'll get a lerp node. So I'll hold L and click, and the alpha will be the lighting. And then we can copy the base color for lighting node up here. And this, again, just returns our base color of the scene without any shadows or anything. So let's hold M and click for a multiply and S for a scalar. And I'll call this shadow intensity. And default value I'll set to be 0.5. So we'll take our color and multiply it by the shadow intensity. And that goes into A. And then the base color default goes into B. So based on our black to white information here, we're going to say where it's white, be the original base color, and where it's black, be the original base color multiplied by 0.5. Now if I plug this into emissive color, it should be similar. Yeah, so this looks correct. Obviously we don't see any color or the sky, but this is more in the lines of what we're going for. Next we can unplug from that, and I'll just select it and drag it over, and then I'll click C and I'll just call it lighting band. Or actually, instead of lighting band, I'll just call it color. We'll just keep it simple, call it color. And then next, let's add a way to tint the shadows or the highlights different colors. If we want to create more of a stylized look where the shadows maybe are a more purplish blue color and maybe the highlights are more of a yellowish warm color, if, for example, if you wanted to do it like that. From there, we can drag off of the lerp node and search for a mask. And we need to make sure RG and B are all checked. Without this, this would return RGBA, which we don't want. We just want the 3 channels. It'll give us errors if we have 4 channels coming from that. And then we can hold M for a multiply, and we'll plug the RGB mask into A. And the B will be 2 colors. So I'll hold 3 and click and do that twice. I'll right click on both of them and convert them to parameters. The top one will be called the tint shadow, and the bottom one will be called the tint highlight. I'll make them both white by default, so that way there's no change unless you go in and specify it yourself. And then we need another lerp node, so I'll hold L and click. The shadow will be the A, the highlight will be the B, and the alpha will again be our lighting that we set up here. Next, we can plug this into the B of the multiply. And then we need to do another one of these masks just to keep it within this RGB range. And then from here, we can select all of this, click C to make a comment box, and we'll just call it tint colors. Next, we just need to add a way to exclude this whole effect from the sky, so that way our sky doesn't become weird looking, and at a certain distance it will just stop working for the cel shading. So to do that, we can right click and search for scene texture again, and this one will be our post-process input 0. Drag this down here. And then off of here, we can search for component mask again, and we just need to make sure it's RGB checked. Then we can copy these 2 nodes and put it up here. And this top one will become the scene depth. Literally, it returns the depth of the scene. We can visualize that. Maybe, there you go. So gives you this black to white mask based on the distance of the pixel from the camera. So we can undo that now. And I'll right click and search for an if node. And then we'll plug in the scene depth to A and the post-process input 0 into A is greater than B. And then the A is less than B will be our cel shader. So basically, based on a certain distance from the camera, we're going to switch from doing the cel shading material logic and just our original scene, which in this case would be our clouds that are far away. So we need a value. So for the B, we can hold S and click for a scalar, and we'll call this disable distance. Wow, I can really not spell today. Let me try that one more time. Disable distance. And let's just set this value to something crazy like 500,000, just to make sure that it's far away and our scene isn't being affected, but only the sky in the very far distance. Of course, you can play with this in your own projects just to make sure that it lines up with everything. That's why we turn it to a scalar. So we're good to go ahead and plug it in to emissive color. Then I'll select all of this and click C, and I'll call this disable effect. Then we can save, and good to go ahead and close out of this. And then we just need to right click on our material here and create material instance. I'll just leave it the same name since I only have the one. All right, now we can click on our post-process volume and search for material. And then there should be an array here under post-process material. You can have multiple post-process materials in here, but for ours, obviously we just have the one. So we'll click this plus one time and then the choose and then asset reference. Now we can click and drag in our material instance, and right away our scene becomes cel shaded. But you will notice some issues right away if you find an area where it's transitioning from light to dark. For example, here we have this moving band, which looks pretty bad. So let's go ahead and fix this now. The couple ways that I found to fix it, one is in the post-process volume, just like our material instances. So I'll just clear the search here and make sure I'm still on our post-process volume. And then from here, I'll search for global illumination. And we want to just check lumen to be off. Now, a lot of people love lumen. It looks great in realistic projects, but for a cel shaded project, in my opinion, you don't need it, and it causes a lot of issues because it's constantly trying to update based on the lighting in your scene. So it works best with this cel shader to have lumen to be off. The next is reflections. So I'll just search this, and we have our reflection method here set to lumen. Now, it might work a little bit with reflections. You can experiment with lumen and screen space, but in my project, I'll just leave it to be none. It helps you get some performance back, and in a stylized project like this, you don't really need nice realistic reflections. And then the next thing that we can do is go to our skylight. And by default, most skylights are probably set to movable, which is, as you can see here, totally dynamic, slowest rendering. And for our stylized scene here, we probably want it to not be super dynamic. So I'll just set it to be static. As you can see, it straightens up the line right away. And if I hover over static, it says static light can't be changed in game, and it's fully baked lighting and fastest rendering. Now, whether or not you're using baked lighting or not, I still believe that it has the fastest rendering and less overhead than stationary or movable, and it looks much better. So I just keep mine on static. The next thing we can do is go to our exponential height fog. And if I just back up a little bit and increase my fog density to 1 or 2, usually this would make the whole screen look super foggy in a normal project. But as you can see here, it's causing some weird issues, and this doesn't look foggy at all. So what I'll do is just set it back to the default, and I'll set the start distance to be 50,000. This just makes sure that it pushes the fog back 50,000 units. Now, if you do want fog in your scene, I highly recommend checking out my material fog video where I show how to create a post-process material that has controls for all sorts of different fog effects. For example, fog based on distance from the camera, so you can have a different color up close, another color in the middle range, and another color farther away. And then also how to create fake height fog, where based on the distance from the 0 point in the world upwards, you can create a fall off of fog, similar to that with the exponential height fog. And it works with the post-process cel shader. So those two materials go hand in hand together. So I definitely recommend checking out that video on post-process fog material. Another tip I have is to fix the sort of weird sheen that you can get at certain angles with the cel shader. So as you can see here, we do get this sort of gradient from the camera outward based on the angle. And here you can see on the left here, this sort of banded line that moves with the camera. Well, this is actually being caused by the specular that is rendered into the scene. And you could go into each material and disable the specular value and just set it to 0. But an easier way is to go into your directional light and search for specular. As you can see here, the specular scale is set to 1. But what it can do is you can set this to 0, and it removes all of that extra specular highlights that we don't need in our cel shader. And now if I adjust the sun to be a more realistic value or an angle, maybe like a 45-degree angle, you can see that it looks great, and there's no weird artifacting on our surfaces because we set our specular scale to 0. You can even see here it says use with great care. Any value besides 1 is not physical. Can be used to artistically remove highlights, mimicking polarizing filters or photo touch-up. So this is a great use case for our material here, for our cel shader. We want to turn this to 0 so we don't get any weird artifacts. Now we can double click to open up our material instance and just play around with some of the parameters that we created. So I'll just turn on everything here and we can take a look. The first is the disable distance. So if I back up a little bit and then lower this value to be much closer to 0, you can see as I bring it down, it becomes more of a closer effect to the camera. And basically it's disabling the post-process effect after this distance. So at 4,115 units here, it's disabling the cel shader and moving back to our default lighting. But what we want to do is set this back to a very high value, so at 500,000, just to make sure that it's not affecting our scene. Maybe we have a landscape in the distance, so we don't want it to affect that. You can play around with this just to make sure it works with your project. The shadow bias is going to be the area in which it switches from being a shadow to the highlight. So if I lower this, you can see it makes the scene brighter, and if I raise it, it'll be darker. Usually you're going to keep this at 0.5. Maybe for an artistic decision, you could increase it to 0.55 or 0.45 on the lower end. But I do recommend leaving it at 0.5, halfway between light and dark. Shadow contrast is exactly what it sounds like. The lower you make this, the less contrast that line will have, and it'll revert more of the traditional lighting. But as we raise it, it becomes a harsher and harsher line to be more and more stylized. So I like it at a value anywhere between usually 50 and 500. For this video, maybe I'll just set it to be 200. You get a little bit of a soft edge on really rounded angles. For the most part, it's still a harsh shading transition between the light and the dark. Next is the shadow intensity. It's just how dark the shadows are. The lower you make this, the more realistic the shading will be. And the higher, obviously, the more stylized, because it looks like it has some ambient light there that's really brightening up the shadowed areas. The next thing that we can mess with is the highlight color and the shadow color. So for the highlight, it's just going to tint anything that it considers in the light. So as you can see here, it's working as intended. What I like to do is just set it to be a little bit of a warm color, so it looks like it's, being lit by the sun. And then in the shadow, obviously it controls the shadow color, but what I like to do is just put it the opposite direction, sort of into the purplish blue territory, just outside the white until you can notice a difference. And that just gives it a nice stylized look, in my opinion. Obviously, you can mess with this on your own and come up with your own colors. All right, that's going to do it for this video on how to create a simple stylized cel shader effect. However, if you are curious on how to take this effect to the next level, I definitely recommend checking out my ultimate post-process cel shader tutorial on this channel, where I go more in depth on how to add effects such as support for colored lights, metallic support, having multiple bands of light, and even how to exclude or include the effect only on certain objects. If you learned anything at all from this video, it'd mean a lot to us if you left a like and subscribe to our channel, and definitely go check out our new game Skyblocker on Steam. This has been Vylocity with Pitchfork Academy, and I'll see you in the next one.